And let's go ahead into the arithmetic now. I cleaned up the tables from the last video, so now we just have all of our numbers nice and pretty. But let's see what we got. So we have some addition, some subtraction, multiplication, division, and then a whole slew of stuff down here. Let's go and take this one piece at a time. So from our concepts, we know that if we're doing addition or subtraction, we want to use rectangular. That's easy to work with. If we're doing multiplication or division, we want to use the phasor notation. That's easier to work with. And you can go back and watch the concept videos if you need to get some clarification on this. All right, so let's look at our first operation. So our first operation has us adding the vectors z1 and z3 together. Okay, so since we are adding, we're going to use rectangular. So z1, 6 plus j3 plus z3 is 5 plus j0. So when we're adding rectangular, we'll take the real parts. So 6 plus 5. And the imaginary parts, 3 plus 0. And this will give us 11 plus j3. Looking at the next bit, we have z2 minus z6. So we have subtraction, so we're going to use rectangular once again. So z2 we see is 3 minus j2. We'll subtract z6. So this is why I had all these conversions. So we're going to, done in the previous video, we're going to use the rectangular form of z6, where originally we had phasor. Turning it into rectangular makes it an easier problem. Z6, so we'll have minus 1.2 plus j 1.59. Like before, we'll take the real parts, so 3 minus negative 1.2 plus j negative 2 minus 1.59. And when we go and do this, we'll get 4.2 minus j 3.59. All right. Now, another one, we have another addition, so we're going to use the rectangular. So z4, we have 2.05. I'm going to skip straight to the adding the real parts. So adding the components. Actually, let's not do that. Let's just go ahead and finish it. 5.64. Keep everything nice and consistent. Okay. Then z5, we have 3.63 minus j 1.69. So we'll add the real parts, 2.05 plus 3.63. We'll add the imaginary parts, 5.64 minus 1.69. We'll get 5.68. Then we'll get plus j 3.5995. There we go. Now let's look at a different one. We have a multiplication now, so let's use our phasor like we had set up here. So phasor, we're going to multiply z6 and z5. So what we're going to do is we're going to multiply these two values together. So we'll do 4 times 2. Then we're going to add the angles together. So it'll be negative 25 plus 127. Another way to write this, and people write this like this. This is fine. Like such. 2 and then 127. These are the same ways of writing that. But when we multiply this out and add, we'll get 8, then 102. So magnitude of 8, an angle of 102 degrees. I'm not looking so bad so far. Z5 divided by Z2. So once again, we're going to use the phasor. So Z5, we said was 4j negative 25. So we'll do 4 negative 25. Z2 we found to be 3.61 negative 33.69. And now what we're going to do is divide the magnitudes out. So 3.61 is going to divide into 4. 4 is, yeah. You get what I'm saying. Okay. Now, instead of adding the angles together, we're going to subtract the angles. So negative 25 minus negative 33.69. So 4 divided by 3.61. This will give us 1.12. 25. This will give us 8.69. Yep. There we go. And one more division problem. We have Z1 divided by Z2. So 6.71 divided by, sorry for scrolling up so much. 26.56. We said Z2 is 3.61 negative 33.69. So 6.71, 3.61, 26.56 minus negative 33.69. Cool, I have these backwards. So instead of me going to fix that, we're just going to do that. It's engineering at its finest, folks. Okay. So we'll get a 1.86, and then we'll do 26.56 plus Angle of 60.25 degrees. And it's very useful to just use the notations that we talked about here, because that just saves you so much time. It's just makes a bunch of two-step problems, and it makes you completely bypass the complex conjugate method we had shown earlier. So now it's going to get fun. What if we have something big like this right here? So we see we've got addition, subtraction, addition, and multiplication. So there's a lot going on here, a lot of vectors. It'll be okay. All we got to do is just treat it like normal. So I'm going to pause the video real quick and write some of these numbers down, and then I'll be right back with you. Okay. Okay. So let's see what we got here. So Z5, 3.63 minus J 1.69 plus Z2 Z2 is 3 minus J2 minus Z1, which is 6 plus J3. Then Z6. So since we have this multiplication right here, I'm going to leave Z6 as its phasor form, because I know I'm going to be multiplying that in just a bit. And also, since we're doing division, it's just advantageous for us to leave it like this. So 2, 127. Okay, so Z3. Since we're adding, we'll do 5 plus J0 plus Z4, which we said was 2.05 plus J5.64. Okay. So all we did was just go and sub in our vectors. Now let's kind of simplify this down a little bit. Come over here. And on the top, what we're going to do is take all the reals, add reals together. Okay. Then up here, we'll take all the imaginaries. Negative 1.69 minus 2 and minus 3. Let's go ahead and grab that real quick, whatever that turns out to be. 3.63 plus 3, 6. So this gives me 0.63. And I'll get negative J 6.69. Just a quick thought. Some people, like, I usually write the J right here. If you write the J right there, it doesn't really matter. It's just up to you. But this is typically how your textbook represents it. Anyway, so we'll go over here. So 2, 127. Group the reals. So 5 plus 2.05 plus J 0 plus 5.64. And when we do that, we'll get 2, 127, 7.05 plus 5.64J. Okay, cool. So we simplified it down just a little bit. Awesome. So at this point, what I would recommend is, since we see that we're going to have a multiplication here, then after we do that, we're going to have to divide. I would suggest putting everything in phasor form. So let's go ahead and do that real quick. I'm going to take this, write this part up here in green. So square root 0.63 squared plus negative 6.69 squared 0.63 squared squared 5. Make sure we're doing that right. Okay. 6.72 for our magnitude. And then our theta angle is going to be tangent inverse of negative 6.69 divided by 0.63. Okay. And that turns out to be negative 84.62 degrees. Now I'm going to take this part here in blue, 7.05 squared plus 5.64 squared. Now we'll get 9.02 for our theta. The tangent inverse 5.64 over 7.05. That'll give me 38.66 degrees. So if we go and simplify that out just a tad bit, we'll get 6.72 negative 84.62 degrees to 127. And we'll get 9.02 at 38.66 degrees. Okay, so now let's go ahead and multiply these two together. Getting a little crowded here, but we're going to be okay. Negative 84.62 degrees, 2 times 9.02. Since we're multiplying, we'll go and add these together. And when we simplify it down, it's 6.72, 84.62 degrees. That would be over 18.04. 165.66 degrees. And notice how we're always staying in between, like with our angles, we're always staying in between 0 and 180, and then 0 and negative 180. Otherwise, we would just have to flip it around to the other respective coordinate. Also from our concepts video, so go back and watch that. Okay, and then for our final act, 6.72 over 15.04. Divide those magnitudes, and then we'll subtract the angles. $165.66. Okay. So here's what we're going to do. So 6.72 divided by 18.04. 0.37 at an angle, negative 84.62 minus 165.66. And we're at negative 250.28. All right. Looks good, right? Not quite. Not quite. The issue is this angle here. We need it to be between 0 and 180, or 0 and negative 180. So I'm going to drag this a little bit over here. This is 0.37, an angle of negative 250.28. So if we go and draw a line, let's see, 80. So negative 250 degrees is like right about there. That's about negative 250 degrees. But remember, we're trying, like I said, we're trying to keep it between 0 and 180, or 0 and negative 180. So because this is outside of that range, all we have to do is draw the line this way. And now this angle right here is just negative 250 degrees plus 180 degrees. That'll give us negative 70.28. Okay. So just know that, like, right here, that's all you have to do. And I know this is going to be a little bit confusing at first when you first try it out, but it does get easier with practice. Just knowing that you've got to keep it in between these two. Kind of a tip, I guess, if you want to call it that, is if you're greater than negative 180, so you're negative 250 here, add 180. And then say if you were, for example, like down here, this is 250 degrees. Then you drew that way. So this angle up here would be plus 250 degrees minus 180. Okay. That 0.28 is just coming from the part up here. But anyway, what I was saying is like, so here, how you're greater than, we have that positive, subtract. So just know that, like, they have opposite signs to get you to the right value. Okay. So our correct answer is going to be 0.37 at an angle of negative 70.28 degrees. That is our final answer. All right. And that is it for the review on addition, subtraction, multiplication, and division of complex numbers. I will see you in the next video where we actually apply some of this stuff. All right, see you there.